Welcome to Chem Plus. Welcome to Chem Plus. With me, King of the Classroom. Today, we have decided to look at practical techniques. For you to pass A-level organic chemistry, you need to understand organic synthesis and these practical techniques. Let's go. Synthesis involves knowing the reaction that's going to take place. What reaction is going to take place? Suppose you want to make an alcohol through nucleophilic substitution. In one of my A-level practicals, they made aspirin. So you got to know the reaction that's going to take place. What are the reactants and what are the expected products? In aspirin, you will need 2-hydroxybenzoic acid mixed with that anhydride to make aspirin. But you can see that your products are mixed there. So the next big thing that you want to think about is, how do I extract this product? How do I extract it? And after that, you need to purify your product. You don't want to start selling impure aspirin, do you? So reaction, extraction, and purification, three most important stages in synthesis. Just how, what are the organic practical techniques? How many of these do we need to know? Right, we need to know reflux, we need to know filtration under vacuum, we need to know distillation, we need to know how to use the separation funnel, we need to know recrystallization, we need to know how to determine melting point and thin layer chromatography. Sometimes they even ask you to sketch a diagram of the reflux apparatus, to sketch a diagram of filtration under vacuum. And oh, what I have seen, some of the diagrams don't look like those diagrams at all. Now then, we are going to start by looking at the reflux apparatus. Students often get in trouble with this apparatus, particularly the water in and water out. They sometimes put them vice versa. Some students, when they're asked to sketch this diagram, they put a bang and they put a thermometer there. Most importantly, you want to think, where have I used the reflux process in my learning? You will reflect when you were studying alcohols. Primary alcohol to a carboxylic acid, we added some reagents and we can convert the primary alcohol to a carboxylic acid. We add acidified potassium dichromate. Primary alcohol goes to a carboxylic acid. Secondary alcohols add acidified potassium dichromate. Reflux, it goes to a ketone. So that's where we've met the reflux apparatus. And another problem is students who are not well read in their chemistry. One student was asking me, but say the granules are not melting. The anti-bumping granules are not meant to melt. They are meant to give you smooth boiling. And one very important fact about the reflux quick fit, it's called a quick fit apparatus. The reflux quick fit apparatus is, you don't use a naked flame. If you choose to use a naked flame, you move the flame across the pear-shaped flask. What you should use in this process is a water bath heat. Your heat source should be a water bath, or you can use an electric heater or a sand bath. If you use a naked flame and the naked flame is static, you are not moving it, it's going to explode. So no lid, no thermometer, check in your water in and your water out, and you are good to go. Now then, we're looking at vacuum filtration. Vacuum filtration is very important because what it does is it gives you a quick and efficient separating of solids from liquids. As compared to the one that uses gravity, you know, where you put a funnel, filter paper. This one is more quick and efficient. That's why we need to use this one. You will be asked to sketch and label all those Buchner funnel, the conical flask with a side arm. You need to know this process, especially when you do the process of recrystallization. Let's go. Now then, we look at this distillation here. When we trying to make an aldehyde from a primary alcohol, we use this quick fit apparatus, the distillation apparatus. Right. If you reflux, remember, if you reflux, you go to a carboxylic acid. But with this one, we put our primary alcohol in there and we add acidified potassium dichromate and distill. We form an aldehyde. Simple distillation may be used to separate a mixture of miscible solids. These ones, they can mix together and you can separate them because they've got different boiling points. Again, you need to watch your water in and water out there. You need to watch your water in and water out. Now then, we want to look at the separating funnel. Usually when you make synthesizing a product, it's mixed with something else. For example, let me take my pen. You can clearly see that the product we have formed here is made of this aqueous layer, which is at the bottom, and this organic layer, which is at the top. A separation funnel may be used to separate a mixture of immiscible. These are products that don't mix with each other. So what you basically do is you put the mixture in the separating funnel, allow them to settle to form two clean layers, then you run off the two layers separately. You run off the two layers separately there. The organic layer is dried using sodium sulfate. They usually give you this as a 3-mark question. They might ask you to sketch this. Some students have done this when they were doing a PEG, practically assessed activity, in year 12 to form an organic product. And there is an exam question that follows this. That is the exam question. If you want, you can pause the video and think about the answer. Butan 2 or sodium bromide. What type of reaction is this? Substitution. So what are we going to form? 2-bromobutane, nucleophilic substitution? Probably. But the question asks you to describe the procedures the student would need to carry out to obtain pure, dry sample of 2-bromobutane. Let's go. Answer is you use a separating funnel, dry organic layer with anhydrous salt. If you give examples of the salt, magnesium sulfate, that will be okay. Recrystallization is a very important technique and it can cost you marks in the organic paper in A-level chemistry. When students made aspirin, the aspirin was not pure. It was not pure. So this is their impure aspirin that they made. What you need is you need to dissolve it in hot solvent. You can see a water bath and solvent there. You dissolve in a hot solvent and now the impurities are now dissolved. You filter the impurities there. The impurities remain in the funnel on the filter paper and your desired product is now in solution. After that, you put it in an ice bath, you cool it, and you form pure crystals of aspirin there. And then you put it on the Buchner funnel, filter under vacuum, and you get pure crystals of aspirin. This is one process that you cannot choose to forget. You can pause the video and take notes here. Right, another process that's very important is determining of melting point. After students had made aspirin there to compare, determine the melting point, your diagram or your apparatus could be slightly different from the one shown on my screen. But once you determine the melting point, you then compare with the melting point of pure product or pure aspirin. Another important technique is thin layer chromatography, which enables us to separate small amounts of solutes. After making aspirin, they had to carry out chromatography comparing pure aspirin and the aspirin they obtained from their experiment. Most importantly, you need to be able to work out RF values and to understand what does RF stand for, retention factor. It stands as a fingerprint for each compound, aiding identification. we want to be able to identify these compounds by comparing array values with the internet. Sometimes in the synthesis of aspirin, your chromatogram, this one here, the spots are not clearly visible. So what we had to do is we had to use what are called locating agents. We used UV light. If you put the chromatogram under UV, you will be able to see the spots more clearly. I think in biology, you can stain with iodine to make the spots or the samples more visible. You need to clearly understand the whole process of chromatography and also the limitations of this process. Like, what are the limitations? Two samples might have the same array value. Right. I hope you have learned quite a bit about these separation techniques. We keep feeding you with what you need for your A-level exams. Let's go.